Our next quadrilateral we're going to look at is a rhombus. And a rhombus is symmetrical along the angles. So if you fold over by the angles, that's one of the cool things about a rhombus. Now, as far as marking up your sides, a rhombus is basically a square where the angles are free to be whatever they need to be. So imagine you built a square out of wood, you didn't reinforce it very well, and you sat on it and it kind of went crooked. That's what a rhombus is, where all four sides are the same length, but all the angles are not necessarily the same. However, the angles directly across from each other are going to be the same. And you can kind of see this by looking at the folding the symmetry. So if you were to fold it along this middle line, you can see how this and this will match up, this and this will match up, this angle and this angle will match up. And then you clear it and fold it the other way. If you fold it the other way, put that back, you will be able to say this angle and this angle match up, this side match up, this side match up. So a lot of this makes sense in the context of thinking about what is symmetrical. I think it's a lot easier to remember what your properties are by just looking at these lines of symmetry. And then let's look at the diagonals and how they behave. Cool thing about a rhombus is their diagonals form a right angle, something that will actually be pretty useful to know. They, like a parallelogram, because they are actually a parallelogram, they do bisect each other. And then you get the angles to also bisect each other. And since that's the more unique property, we're going to focus on that with our limited space here. We're going to say this angle here, it gets cut in half, this angle gets cut in half, and these are actually the same. This angle here gets cut in half, and this angle here, same measures, get cut in half as well. So that's one of the more unique things about a rhombus and its diagonals. So we have four equal sides, so four congruent sides. We see that we have opposite angles are congruent. We also see that our diagonals are perpendicular. We represent that with an upside down T. Diagonals are perpendicular. And diagonals bisect angles. And by bisect the angles, we're talking about this thing right here, where the angles get split in half at each corner because of the diagonals. So let's move on down to rectangles. Rectangles are also parallelograms, but they have 90-degree angles. Looking at our symmetry first, it's just like the rhombus in that we have two lines of symmetry, but instead of going through the corners, we go through the middle of the sides with a rectangle. Looking at our properties here, most important thing that we're probably used to even from early grade school is that our rectangle is going to have 90-degree angles inside. We're also going to have opposite sides being equal to one another. And like a parallelogram, opposite sides will also be parallel to each other. Moving on to the diagonals of a rectangle. One of the neat things about a rectangle is that the diagonals, not only do they bisect each other like a parallelogram should, but they also are equal to each other. And you can in fact show that each of the parts, since they bisect each other and they're equal to each other, each of these four little parts are all going to be equal to each other in a rectangle. So let's write down some of these key properties here. Has four right angles, two pair of congruent sides, 2 pair parallel sides, just like a parallelogram. And then it has congruent diagonals. One of the things you might be noticing is that whenever I reference something like a rectangle as being a parallelogram, it actually inherits all of its properties. So everything that was true about a parallelogram up here, all of these things are also true of a rectangle. In addition, we get the congruent diagonals and the 4 right angles. So what we're doing is we're just building on and saying, I'm a parallelogram and then some. And a square is kind of cool because it is exactly that, but it does it from 2 sources. A square is a rhombus, but a square is also a rectangle. So it inherits everything that a rhombus can do and everything that a rectangle can do, which both inherit from parallelograms, which inherits from quadrilaterals. So you can see that squares are going to have a whole ton of properties. First one, looking at its symmetry, you can fold a square the way you fold a rectangle. And you can also fold a square the way that you would fold a rhombus. So there are 4 lines of symmetry in a square, which is going to lead to a whole bunch of properties. One of them being that no matter how you fold it, your sides are going to end up landing on top of each other, so you have 4 equal sides. No matter how you fold it, your angles will fall on top of each other, so you're going to have 4 equal angles. So they're also going to be parallel when you're looking straight across from each other, just like a parallelogram would be. And when you look at the diagonals, you get a whole bunch of things as well. So with the diagonals, you inherit, this actually comes from kites, believe it or not, the ability to get a 90-degree angle perpendicular diagonals. You also get the rectangle property of these all being congruent to one another, all these diagonals being congruent to one another. And then you inherit some of the other properties, such as in a rhombus, how these all split each other, but since all 4 sides are equal, they're all going to be equal, and in fact they're all 45 degrees. And so what you begin to see is as you inherit more and more of these properties, they become incredibly symmetrical when you get to a square. The last one down here is a kite. And a kite is something that you can fold directly in half. And the way a kite is most simply understood is that you have a pair of adjacent sides that are next to each other, and another pair of adjacent sides that are right next to each other that are congruent. So this is the simplest way of looking at a kite. Because you can fold it in half, you get these angles directly across from each other that are going to match up. So if our line of symmetry is right here, these things are going to match, these are going to match, and these are going to match. So that line of symmetry is definitely your friend when understanding how kites work. Moving on to diagonals, a lot of things that are useful about the diagonals of kites, so this is a good one to remember. First of all, we get that 90-degree angle, kind of like we had in the square above, right in the middle where the 2 diagonals intersect. Because it's symmetrical, we know that these are going to be equal to each other. Not necessarily true the other direction. So the top and bottom, these are not necessarily equal to each other, so we're going to leave that out of there. The other thing the diagonals do is they split things directly in the middle on the top and bottom. So the 2 angles on top and the 2 angles on bottom are being equal to each other because they were bisected from the original angle. Note that the top angle and bottom angle are not necessarily the same. This angle right here should be equal to this angle over here, and then this angle over here will be equal to that one. Again, it goes back to that symmetry piece. You can fold this thing in half down a line like this, and everything on both sides is going to be symmetrical. So writing out the properties of a kite, we have 2 pair of congruent sides, and I'm going to put in parentheses adjacent. And we can actually go up above and say, for the two pairs of congruent sides, we're going to add opposite next to those, because the congruent sides are not necessarily next to each other. They have to be opposite each other in the parallelogram rectangle situation. So let's update that and then go back down here and specify that these are adjacent to each other. Another thing we have is the diagonals are perpendicular. And angles that are on opposite sides of the center diagonal are going to be equal to each other. That one's a little bit harder to write, so I'm going to say just look at the picture for that one so that you don't confuse yourself.